How to solve constant intervals for both means and proportions. This is going to be our first example of a constant interval for a mean. You must estimate the mean temperature in degrees Fahrenheit with the following temperatures. Find the 90% confidence interval. So right here is going to be our formula. It is going to be x bar plus or minus T of A over 2 times the standard deviation over the square root of n. The x bar is going to be our mean or our average. And we're going to highlight everything, just make everything a little bit easier going through it. That way you know where everything is and where it's coming from. So first we have to find our n, that is the total amount in our sample. So here we have 7. And then next we're going to look for our x bar being the mean and our s, the standard deviation. The equation to find A is 1 minus whatever percent that it's asking you to find. And that we get 1 minus 0.9 gives us 0.1. And now to find the T of A, we'll do the 0.1 divided by 2, which gives us 0.05. And that is what we're going to use on our chart to find the number that we need. But to do that, we have to find our degrees of freedom, which in this case, it is going to be n minus 1. So 7 minus 1 is going to give us 6. Just give me a second here to highlight everything. And then we're going to go over to our critical values of T chart. We go to the side to the degrees of freedom of 6 and the T value of 0.05, and that gives us 1.943. And now to find our average and our standard deviation. The best way to do that is just put the numbers into Excel, put equals average, highlight your numbers, and then for the standard deviation, we will do the same thing. You just want to make sure when you find the standard deviation, you are doing it for the sample, as this is a sample size and not a population. So it'll be stdev .s, and then highlight everything, and then that gives you your standard deviation for the numbers. And we're going to move the formula down back to the bottom, make it a little easier to see as we solve this out. So we're going to start with our x bar, which is 69.7429, plus or minus our T of A over 2, which is going to be 1.943 times the standard deviation, which is going to be 4.60285 divided by the square root of n, which is 7. One thing you want to make sure when solving these is don't round your numbers early. Wait till after you're done with the equation and then round to wherever the problem tells you to, but use your full number when solving the equation to keep from having rounding errors in your final answer. So we're going to solve what's in the parentheses first, just to kind of keep away from having any errors. So the easiest way to do that is just put it in your calculator. And that is going to give us 1.739713,775. We're going to multiply that by 1.943, and that will give us 3.380263864. And that is going to be the number we're going to add and subtract from our x bar, which is 69.7429. And so we're going to start off by doing the addition first. And just put that in your calculator. And that is going to give us 73.12316. And then we're going to do the same thing, but we're going to subtract this one. That is going to give us 66.36263. And then so there are the numbers you're going to use for your confidence interval. Which our confidence interval was a 90% confidence interval. You can see that up at the top, and then it accidentally highlighted the wrong thing there. Just give me 1 second. And we're going to do it to 2 decimal places. So the first one is going to be 66.36 to 73.12. Now that we have our numbers, we have to write out our confidence interval. In which for that, we're going to say that we are 90% confident that the true temperature mean is between 66.36 and 73.12 degrees Fahrenheit. And I just went back up to the top just to ensure I was writing the right thing. It's always good to go back to the original problem to make sure everything's correct. Now we're going to be showing an example of a confidence interval for a proportion. So, in a sample of 420 adults, 361 had children. Construct a 90% confidence interval for the true population proportion of adults with children. So we know it's proportion because it's 420 or is the total sample. We got 361 out of that. But it also tells us it's a proportion, but we would use that if it didn't. The equation for this one is going to be p hat plus or minus z of a over 2 times the square root of p hat times 1 minus p hat over n. So for our p hat, the way that you find that you will do the total number that you're looking for out of the sample. So it's going to be 361 being the number that who had children out of the 420 total sampled. And we'll just put that in our calculator real quick. And that gives us 0.85952. 381. And we're going to use that full number. That way we don't have no rounding errors, just like before. And that number right there is going to be our p hat. The next thing we have to do, we have to find our a. We'll do that the same way as we did for the mean, where we do 1 minus 0.9, and that's going to give us 0.1. And then for the z of a, we're going to have to divide that by 2, and that gives us 0.05. And then we're going to use a different chart this time, the cumulative probability of z. And this time we're going to look for the 0.05, which if we look down there, the closest thing we got is 0.0505 and 0.0495, which in the middle of that, perfectly middle would be 0.05. So we will go to the middle of those two numbers, gives us 0.645. And over on the chart, it was the negative number, but we're going to use the positive number of that. And then so now we're going to start filling out our equation. So we're going to put our p hat plus or minus the z of a. I'm going to try keeping everything highlighted just so you can see where everything's coming from and what it is. Take a minute to write this down. And we're just going to put this in our calculator, but the best way to do it is to still do it separately to make sure that you don't have any mistakes. The more you put in your calculator, the bigger chance you have of having a mistake putting something in. So I just like breaking it up and doing it separate, and then it also lets you keep track of what you're doing. So we got 0.000287482. And then we're going to find the square root of that number, and we'll multiply that with the 1.645. And that is going to give us 1.645 times 0.016955294. And that number is going to be 0.027891459. And we're going to start off by adding that to our p hat. I'm just going to highlight everything, show you where everything came from. And I'm just going to put the two highlights on the one number to show that it was the two numbers that combined to solve that. And then after we add them together, we're going to get 0.887415, And we're going to do the same exact thing, but this time we are going to do it by subtracting. And that number is going to be 0.831632. And I didn't write the full thing out on both of them because I knew we were done with this equation and that we were only going to 3 decimal places. So I didn't see the need to write out the full number, knowing that that was the end of all the math we're doing with these numbers. So we know that the proportion is between 0.832 and 0.887. And so now we have that. We're going to write out our confidence interval, which we are 90% confident that the proportion of adults with kids is between 0.832 and 0.887. And this example is complete. Thank you for watching this video, and I hope that it was helpful to you.